Fukushima, a Fuking Disaster by Tiffany, Hunter, Sophie, and Michael.
What happened? March 11th, 2011, a magnitude 9.0 earthquake off the coast of Toku, Japan, caused a tsunami that sent a massive force of water hurtling towards the Fukushima nuclear power plant. Due to the location of the plant, located near the coast, the impact of the wave caused failures in safety systems at the plant. Most important of these systems being the water cooling pumps. Without these pumps functioning, the reactors of the plant fell into the throes of multiple meltdowns. The compromised plant then leached radiation into many environments. So some of the context for the earthquake: a 0 to 10 scale is used for the Richter measurement, and a 0 is something that cannot be felt, and a 10 is a very catastrophic earthquake.
How did this happen? Historically, this size and type of event is nothing new. In the mid-1980s, the Chernobyl disaster, followed by a similar path of that of Fukushima. A meltdown took place during a safety stress test. This caused 2 immediate deaths from a blast after the initial reaction, almost 30 more by acute radiation poisoning. By the time the Russian government had contained, not fixed, the situation, it had cost them 18 billion rubles and the effort of countless workers. This disaster helped the title of the worst nuclear power plant failure till the onset of Fukushima. So, given the past lesson, how was this sort of disaster able to reoccur?
Important factors: speed of onset. While some steps were taken during the earthquake, such as the SCRAM procedure, the tsunami that crippled the plant hit only 50 minutes after the earthquake.
Human and economic losses. There were no casualties caused by radiation exposure. A few of the plant's workers were severely injured or killed by the disaster conditions resulting from the earthquake. At least 6 workers have exceeded lifetime legal limits for radiation, and more than 175 have received significant radiation doses. Workers involved in mitigating the effects of the accident do face minimally higher risks for some cancers. Predicted future cancer deaths due to the accumulated radiation exposures in the population living near Fukushima have ranged in the academic literature from none to hundreds. On December 16, 2011, Japanese authorities declared the plant to be stable, although it would take decades to decontaminate the surrounding areas and to decommission the plant altogether. The earthquake and tsunami killed over 15,000 people from effects unrelated to the destruction of the reactors at Fukushima.
Primary responses. More than 20,000 people were killed when the earthquake and tsunami struck. Tens of thousands had to be evacuated as radiation leaked into the atmosphere, sea, and food chain. The 6-reactor Fukushima nuclear plant was badly damaged by the earthquake and tsunami, with blasts occurring at 4 reactors after the cooling system went offline.
Secondary response. The U.S. electric power industry has conducted reviews of the incident at the Japanese facility and compiled lessons learned from the event. Nuclear power plant operations translated these lessons into actions with the goal of making already safe U.S. reactors even safer. Key actions taken by the industry include development of new mitigation strategies that will allow nuclear power facilities to handle even a catastrophic natural event that simultaneously affects all reactors on the site and prevent a radiological release. These strategies and the equipment necessary for their implementations are collectively referred to as flex capabilities. Establishment of 2 national response centers, one in Memphis, Tennessee, and the other in Phoenix, with a wide array of disaster response equipment that can be delivered to any site within 24 hours. Revertification of the plant's designs can withstand severe natural events such as a flooding or earthquakes. Upgrades to the plant's safety equipment. enhancements to emergency response capabilities, such as more robust communication networks and improved procedural instructions, also training plant workers on new strategies, equipment, and procedures.
Recovery time. Decontamination and decommissioning work is expected to continue for between 10 and 30 years from the date of the disaster. The affected reactors were adjacent to one another, and accident management was made much more difficult because of the number of simultaneous hazards concentrated in such a small area. Failure of emergency power following the tsunami resulted in loss of coolant from each reactor, hydrogen explosions damaging the reactor buildings, and water draining from the open air spent fuel pools. Plant workers were put in the position of trying to cope simultaneously with core meltdowns at 3 reactors and exposed fuel pools at 3 units. Automated cooling systems were installed within 3 months. A fabric cover was built to protect the buildings from storms and heavy rainfall. New detectors were installed at the plant to track emissions of xenon gas. Filters were installed to reduce contaminants from escaping the area of the plant into the area or atmosphere. Cement has been laid near the seabed to control contaminants from accidentally entering the ocean.
Severity of Fukushima. The severity of the event is similar to that of the Chernobyl event mentioned earlier. It is rated as a 7 on the International Nuclear and Radiological Event Scale, putting it on par with Chernobyl. Additionally, milk from the areas near the event were contaminated with radiation and caused thyroid cancer, and around 300 tons of radioactive water is added to the Pacific Ocean every day.
Fukushima impact. Water from the nuclear reaction coolers leaked into the ocean. Radiation hotspots were found in neighborhoods around Fukushima and were deemed unsafe. This nuclear meltdown could have been much worse if the plant manager, Maso Yoshida, didn't start pumping seawater into the reactors when they ran out of fresh water. After he did this, corporate headquarters of TEPCO, the company that owns Fukushima, ordered him to stop immediately because he could permanently damage the reactors and cost them a lot of money. But Yoshida disobeyed these orders and kept pumping seawater into the nuclear reactors to cool them, preventing further devastation to the area.